Hello, I'm going to be talking about sinusoidal waveforms. Sinusoidal waveforms are continuous signals, so they continue on for all time, but we often look at them as discrete signals. So we take samples of sections of the big continuous waveform and look at them specifically as we take as a big load of numbers. We can graph and look at them much easier. So there's three main factors for a sinusoidal waveform: frequency, amplitude, and phase. So for frequency, it's usually measured in hertz, which is how many cycles the waveform goes through in a second. And you can see it here. This waveform has 0.4 hertz, so it goes through, I believe, 2 cycles in 5 seconds. And then it can also be looked at in radians per second, so how many radians it goes through per second, and then also radians per sample. So in between each sample, how many radians does the waveform go through, which can be visualized over by this circle here. It's just how far it moves along the circle in between each sample or per second, depending on what we're looking at. The amplitude of the waveform is how high or low the waveform goes. In this case, it is 1. So it goes up 1 and it goes down as far as 1. And that phase dictates where the waveform starts, kind of. For this example, you can see if I change the phase, it starts up here instead. And waveforms can be out of phase with each other. So one can start with, if it has 0 offset, same function, 0 offset, would start in the middle still and would be out of phase. They wouldn't be in line with each other at all. But so they'd be out of phase by a certain phase angle. So waveforms are often looked at as complex numbers, which I've used here in MATLAB to do. So I have 2 waveforms here and here, and they've been converted into complex numbers here and added together. And added together here as well, just as they're using the normal functions. And we have this graph here, which shows that those red X's are the graph of the complex number waveform, and the yellow line is when before they converted to complex numbers, and it's the exact same. But we use complex numbers because it's much easier sometimes to work with, and when you have the same frequency and in a waveform, it just makes it much easier to add, and it's easier to work with and can be very useful for explaining specific things.